Good afternoon, advanced algebra students. I hope you are doing great. We are continuing on in chapter 4 of our Algebra 1 book. Again, we're taking this detour just to make sure that everybody has a very thorough understanding on how to solve systems of equations. We have already talked about solving systems by graphing. Our last lesson talked about solving system by substitution. Today, we're going to learn about solving systems by elimination. Now, even though these are three different methods, we are trying to accomplish the same thing, and that is we are trying to find the point where two lines touch, or if they touch everywhere, like if they're the same two lines, or they don't touch at all if they're parallel lines. All right, so let's start off with a very straightforward example. Example number 1 is x plus y equals 7. And our second line is 2x minus y equals 2. Now, at some point, how you solve a system of equations is a matter of personal preference. For me, I don't typically use graphing because that's more time consuming. And then between substitution and elimination, I look at how my equations are set up. If I have the x and y on one side in both of my equations, I typically do use elimination, because I don't want to have to isolate the x or y to use substitution. I would have to do an extra step. So in this particular case, it's actually even easier than normal because the coefficients of y are opposites of each other. The first y has a kind of an invisible positive one in front of it, and the second y kind of has an invisible negative one in front of it. So we have opposite coefficients. When I add these two equations together, I get 3x equals 9. So y minus y is 0, and that just drops out. Then I divide both sides by 3 to get that x equals 3. Now keep in mind, we're not done yet because we're trying to find the point where these two lines cross. This is just the x coordinate. What I need to do is reuse one of my original equations. I'll use x plus y equals 7. And then plug in the 3 that I just found to get that y equals 4. So the answer is going to be 3, 4. Remember, we're always hoping to find that point where the two lines cross. All right, let's do another fairly straightforward example here. Example number 2, our first line is x plus 3y equals 7. And our second equation is 2x plus 2y equals 6. Now notice the first step has not been done for us in this case because neither of the coefficients are opposites of each other. So the coefficients of x are not opposites of each other, and the coefficients of y are not opposites of each other. However, I can make them be opposites. I can keep the second equation the way it is, and then with the first one, I can multiply everything I see by -2. And I always make a note of that so I can kind of keep track of it. So this is going to become -2x minus 6y equals -14. And then positive 2x plus 2y equals 6. So when I do that, and I add the two equations together, I get -4y equals -8. And then when I divide both sides by -4, I get that y is 2. And again, I can go back to either of my original equations. The first one seems a little more straightforward here, so I'll use that one. I know that x plus 3y equals 7. But since I just found out that y is 2, I can plug that in there and get x plus 6 equals 7 or x equals 1. So the point where these two lines cross is the point 1, 2. All right, so those were fairly straightforward. Let's go ahead and talk about something called equivalent systems. So I believe that this does come up in your homework, and that's why I wanted to do an example here. To say that two systems are equivalent means that you can multiply both equations in the first system by a number that will give you both equations in the second system. So let's go ahead and look here for example 3. our first line is x plus 2y equals 4. And our second equation is 2x minus 5y equals negative 1. That would be system 1. Our second system will be 2x plus 4y equals 4. And then on the second line, we have negative 2x plus 5y equals 1. So go ahead and look at those two systems and tell me, do they look equivalent to you? Yes or no? Why or why not? The first thing you might notice is that these two equations are equivalent, because I can take the first equation and multiply by negative 1 to get the second equation. So that is a good sign. Now what we want to do is look if we can get this equation from the first equation in the first system. Let's try multiplying everything by 2 and see what would happen. If we multiply x by 2, we would get 2x. 2y times 2 would be 4y, but here's where we run into a problem. 4 times 2 would be 8. So in order for these two systems to be equivalent, I would need this to be an 8. So I'm going to say here, no, the systems are not equivalent. And again, the reason is because there is no number that I can multiply the first equation by to get the second one. All right, now I just want to close with example number 4, which is a word problem. And by the way, those of you that are taking the time to do the notes, I do try to pick word problems in the notes that are similar to test problems or potential test problems. All right, so let's do example number 3. No, this will be 4. Example number 4. Again, you don't need to write down what I say, just what I put on the board. So 4 cheeseburgers and 2 fries cost $29.70. 2 cheeseburgers and 3 fries cost $20.75. How much does each cheeseburger and each fries cost? In this particular case, it might be helpful to use letters. So C is going to be the cost of a cheeseburger, and we'll have F be the cost of some fries. So the cost of fries. And again, when we're working with word problems, we do want to label our variables at the beginning. Now, because we have 2 variables, we're going to need 2 equations. So it says 4 cheeseburgers and 2 fries cost $29.70. So I'm going to write 4 cheeseburger plus 2 fries equal $29.70. Okay, then for the second equation, I'm going to make a note of the fact that 2 cheeseburgers and 3 fries cost $20.75. So 2 cheeseburger and 3 fries cost $20.75. Now, if I want to solve this system by elimination, and I do think that that is the easiest method here, I either need to make the coefficients of C opposites of each other, or the coefficients of F opposites of each other. And one way you can kind of think about this is, what would be the lowest common denominator for their coefficients? Now, we can either change the coefficients of C or F. It doesn't really matter. It looks like in my particular example here that I changed the coefficients of C to be opposites of each other. So I took the second equation times -2. So I'm going to say to keep the first one and then multiply the second one times -2. So the first equation is going to stay 4C plus 2F equals $29.70. And the second equation, when I multiply it by -2, is going to become -4C minus 6F equals, let's see what we've got here, -41.50. Now, I'm going to add those 2 equations together. When I do, I get -4F equals -11.8. Dividing by -4, I get that F equals 2.95. So French fries cost $2.95. Now, to find the cost of cheeseburgers, I just go back to either of my two original equations. I'll just pick the first one here. I know that 4 cheeseburgers and 2 fries is $29.70. I also know now that fries cost $2.95, so I'll plug that in. When I multiply the 2 times $2.95, I get $5.90. And then when I subtract that from $29.70, I get 4 cheeseburgers equals $23.80. Dividing by 4, I get C equals 5.95. In this particular case, unless you were asked to, you don't necessarily list the answer in ordered pair format, but you would say the cost of a cheeseburger is equal to $5.95 and the cost of fries is $2.95. I hope that's helpful. Talk to you soon, guys. Bye.